Let's take a look at this guided practice on determining the calculating significant figures. So we have a couple of rules here, or guidelines, that we're going to take a look at, and I'm going to go ahead and use highlighters to identify for each one of these the number of significant digits that I have. So that's the first thing when we're doing sig figs. We want to start there. That's not what we focus on, it's just where we need to start in our learning. And so for this first one, it says all non-zero numbers are significant. And so what we do is just, I can go through each and every one of these examples and determine anything that's not a zero is going to be significant. Okay, so let's go ahead and I'm going to highlight those. The zeros are where we get into trouble. So that takes care of that first check mark there for our guidelines. The second one, all sandwich zeros are significant. And so what I want to do is find sandwich zeros, zeros that fall between non-zero numbers or between significant digits. And so in example B here, both of these are between significant digits, so they are going to also be significant, or sandwich zeros. And then for the last one, all zeros that are going to be right of the decimal and at the end of the number. Okay, it has to be both. Those are significant. And so they're telling us the precision and accuracy, or the precision of our instrumentation. And so this one here in A is right of the decimal. It's going to be, and at the end of the number, it's going to be significant. And then in F, it will be that way. That 0 is, and then also H, that 0.00, those are significant digits. Times 10 to the second, that is actually placeholder values. We don't need to worry about that, but anything that's going to be in scientific notation, that times 10, we don't worry about those values. Now, the two that I didn't highlight for D and E, those zeros are actually just going to be placeholders. And so while the ones in D are right of the decimal, two of those are right of the decimal, they're not at the end of the number, and so they are just placeholders. And also with letter E, these two are at the end of the number, but they're not right of the decimal. And so make sure that you take a look at that very carefully when you're trying to evaluate those. So that's the first step with significant figures, is just being able to determine them, because when we start to do problem solving, we have to be able to figure out what we should report our final answer to. And so if we want to know how many, that number, so let's do this, that number that we have here. So in A, there are 2 of them that are significant, B, all 4, C, 5, D, 3, so just the ones that are highlighted in blue are significant. And so this is kind of more of a mental task most of the time for us, but while we're first starting to practice this, if you're new to significant digits, or if it's been a while, we can take a look at them this way. Okay. So after that, what we want to do is start applying these rules when we are doing mathematical processes. And so there's really 2 rules. Now, we know it gets more complicated than this, because eventually we're going to put in multiple applications, multiple math things that we might be doing, and then we have to kind of go back and see what the practice is for doing that. But for right now, when we just add all of these things up, how do we report our final answer? And so for letter A, and there's 2 rules, 2 different rules, and so let me kind of circle these here. If we are adding and subtracting, we have one rule. If we're multiplying and dividing, we have a separate rule. So let's start with adding and subtracting. So for adding and subtracting, we want to round our place value to the fewest places right of the decimal. Okay. The first thing you should do, always, calculate first. So I'm going to do that over here. I'm going to say, okay, calculate first. First, then round, okay? So that's how we want to do this. So the first thing we're going to do is go ahead and add all these numbers up. And so when I did that earlier, I got 24.276. Okay, now after I've done the calculation, I go back and I take a look, and it looks like we only have one place value right of the decimal in this number. So you look at all 3 values that you're adding. What's the fewest place values right of the decimal for any of those? And so that means that we're going to only have one place value right of the decimal. Now we use that next digit, only the very next one, to round. Okay, so since this value is greater than 5, so 7 is greater than 5, we're going to round up. And so our final answer, what we would write for our answer, is going to be 24.3. And that would be our answer reported to the correct significant digits. There is actually a way to do this in some of the TI calculators. I don't actually use it myself because I just know the rules, but there are some ways of doing that. I think you have to be quite particular in how you enter your values to begin with. Okay, the second one, we're going to subtract. I already did the math ahead of time, and I got, let's see, what was that one? 4.972. In this one, the fewest place values is going to be 2 place values right at the decimal because we have 3 on that first value. And so we're going to round to 2, the second place, the hundredths place. The 2 is less than 5, okay, so we're going to keep the same. So 2 is less than 5, so we're going to keep that value the same. Just some rounding rules. And we end up with a value of 4.97. So that's how we add or subtract values and then report our numbers to the correct significant digits. So when we multiply and divide, which I would say is probably more common in our mathematical processes in chemistry, what we want to do is we want to go ahead and round to the fewest total number of significant digits. So this is where we go back and we say, okay, in C, 17.6 is 3 significant digits and 3.2 is 2 significant digits. So the fewest number of significant digits is going to be 2, right? So we have 1, 2 values here. So again, I do the math first, then I round. So the math on this, we get 56.32, but I only want to round to 2 significant digits. So with sig figs, okay, and a lot of times I'll write an arrow or an equal sign and I'll write SF for sig figs, it should just be 56. I know this gets a little strange sometimes, but this is the process. This is what we do in chemistry and physics. All right, for the last one, let's go ahead and take a look at those. The first one, now it's not always going to be that the first one or the second one's going to be, it's whichever one has fewer total significant figures. So the second one has 3, the first one has 4, because those trailing zeros, remember that one is right at the decimal at the end of the number, which puts the other one as a sandwich, and so this one has all 4, and this one only has 3. So 1, 2, 3, 4. 1, 2, 3. So 3 is going to be the lesser of those two. So we do the math first. I get 61.53846. This is where it really starts to become important. In math, a lot of times they'll tell you how to round your value, but in science we have to know these sig fig rules. So we're going to round to 3 significant digits, 1, 2, 3. 3 is less than 5, so I'm going to keep that value the same. And with sig figs, this value is going to be 61.5. I hope that's helpful for you. Try some of the independent practice.